Okay, this is the third video in for lecture 6. First one dealt with the class stack. The second one dealt with a templated stack. And the third one deals with a queue. So a queue abstract data type. A queue is a first in, first out data structure. Remember, a stack was a last in, first out. So this is a first in, first out. Okay, so let's start with this nice little artistic rendition here. You guys probably all know what that is, right? This is a queue. It's people that are lining up to buy a ticket to go in and see a movie. So first one in line, first one out. And then everybody moves up. And the next one gets a ticket, and everybody moves up. And the last one, like that. So first one in line is the first one out. And everybody shifts forward. That's the first in, first out. So now we'll take a look at a queue. Q-U-E-U-E, I think that's usually how it's spelled. And a queue then, remember with a stack, basically we had an array and we had a variable called top. And top pretty much controlled everything what was to happen with the stack. With a queue, there's two variables, not just top, but there's one called front and one called rear. You can call it back or rear, whatever. And the idea is that I've drawn the array. I've drawn it sideways, where kind of like the people lining up at to buy a ticket. So the front would be here, and the back would be here, so to speak. Okay, if you recall with a stack, there's a push function and a pop function. Push is to put something into the stack. Pop is to take something out of the stack. With a queue, we don't use the word push, we use the word in queue. I don't know why, that's just, and it may be changing now. I mean, I've seen queues where they actually use the words in queue and DQ. But DQ means to pop, in queue means to push. Okay, if you recall with a stack, we always pushed at the top and we always popped from the top. We just used the one variable. Having a hard time getting that to stay off to the side there. There we go. So, but with queue, we always push or in queue from the rear or back, and we DQ or pop from the front. So to start out with the queue, we can actually assign, well, if you think about it, when the queue is empty, front and rear need to be at the same place. So we can do something like front is assigned 0, rear is assigned 0, like that. And that means, you know, these are not pointers, they're just variables. But really it's kind of saying that, you know, here's front and here's rear. They would have to start out at the same place because there's nothing in there, so the front and rear is the same. So we can do that. That's no problem at all. However, if you recall when we did the stack, that we actually assigned top to -1. Whoops, I'm sorry, I should have done it like this. Doggone it. We can assign it, we can do it like that. We did it like that. And here we could actually do the same. So in that case, remember with push, we did top plus plus first. That's when we used the push function. Top plus plus, which made top 0, and then we pushed it on the top of the stack. So we could do that with NQ and DQ. We could do that, but we don't really need to. We could just set them at 0, or in our code here, I'm just going to go down to the code for a second. See, here's the array in front. Oops, it ran onto the next page. I wonder if I could move that down here a second. No, I can't do that right now. That's all right. It doesn't matter. All right. Anyway, so we have front and rear. We don't just have top. We have front and rear. Okay, but check this out right here. Here's the constructor. Front is assigned rear is assigned size -1. So that it's not assigning front and rear to here. Whoops. Come on, Dennis. Sorry. Okay, so it's not assigning front and rear to 0, which you could. But instead, if you recall, it said front is assigned rear is assigned size -1. Well, size is 10, so size -1 is 9. So it's basically putting 9 here and here and assigning them right here, front and rear. And so they're both 9. And that works fine too. Here's the bottom line is you can assign front and rear to start at 0, to start at -1. You could have it start at 4. You could say, they have to be the same though. They have to be the same. And by the way, I did this, I chained it together. I don't know if that's considered good coding style or not. I got it out of a book years ago. You know, if you wanted to be, you know, I don't know if it'd be any better or not, but you could just do, excuse me, this is in the constructor. You could just do it as separate statements. Front is assigned size -1. Rear is assigned size -1. And that's what, oh, here, I even put that in there. There you go. So that's the way I did it, but you could do it like that. I'm sorry, I didn't see that. I wrote it a long time ago, I've forgotten. Okay, so at any rate, in the particular program that we're doing, we're starting front and rear at 9, right here. Okay, so a golden rule, so to speak, is we always in queue, that's push, we always in queue at the rear. Well, the rear is right here. So if we in queue, now let's just for a moment, let's go to main and just see how we declare main. So if we declare, makes a nice queue. If we declare an object, just for now, for the sake of not having to write too much, I'm just going to use the letter Q because that's a Q. Okay, so here's we're going to call the object Q. I know that's not good coding style to use a single letter, but it'll be easier for me in this discussion. Okay, so we have this object called Q, and we know that the object then is basically going to be this right here, isn't it? It's going to be an array and a front and rear variables. And we also know that when the constructor gets called, it's going to assign, front will be assigned -1 and rear will be assigned to -1. Okay, here's the constructor right here. Front and rear are both assigned -1. So that's front and rear right there. So if we then in-queued or pushed an item into the queue, remember golden rule, we always in-queue at the rear or the back. So we would say q.inqueue. By the way, I think that I was very French when I wrote this. Let me go back to the nodes because it's kind of silly. Let's go to NQ. Yeah, look, I've got more U's in there than a man needs. That's for sure. So I don't know. I don't know what I was doing. Just do it that way. NQ. I've got an extra UE on here, which I have no idea why I did that. But I don't know. I just keep forgetting to change it. So just if you're writing your own program, I would just do it like that, just NQ. And same with here with DQ. Okay, just do it NQ and DQ with not that extra UE at the end. Okay, so if we NQ into the queue, like push a 7, we know that it's going to NQ at the rear, so it's going to put a 7 there. Okay. Well, do you remember when we did the stack, when we did the push function, push a 7 or something? Remember inside the function itself, the first thing that happened was top plus plus, and then we said items top is assigned the item that's coming from main. This could be called item. And so it incremented top first, and then it put it into the stack. Okay, well, in this case, it's kind of the same thing. We increment rear. We say rear plus plus. Well, that's a problem. That's a problem because rear plus plus, if rear is 9, now rear is 10. And there is no 10. What we really ought to do, and what we do is we want to move to here. We want this to be circular. And so when it gets to 9, we want to go to 0. Well, we can do that if we do it this way. If we say rear is assigned rear plus 1, that's the same thing as rear plus plus. If we do that, and then we mod it by size, like that, well, size is 10. So what do we really have? We have rear plus 1, that's 9 plus 1 mod 10. So we have 10 mod 10, which is 0. So if we do this right here, rear is assigned rear plus 1 mod size, it's going to put rear at 0. Okay, so here it is right here, rear plus 1 mod size. So again, if rear is 9 plus 1 is 10 mod 10, it's 0. So now that means that rear is 0. So rear started out at 9, but now here's the NQ function. We want to push or NQ something. So we move rear to 0, and then items rear, which is 0, is assigned, I think it was a 7 and we assign a 7 to it. So now in this array, we now have a 7 there. So rear is actually, in a sense, it's not a pointer, but in a sense you could say rear is now here. And front is still at 9, right? At this point right here. This is front. So rear and front are not pointers. They simply are variables that hold the front, where the front and rear are. But let's say we want to push another one. Not push, NQ another one. We're going to NQ a 3. Okay, rear is 0 now. Front is 9. Okay. And now we're going to call NQ, and we're going to NQ a 3. We'll do it right here. Q, whoops. Q dot NQ 3. Let me just get rid of all this stuff. We're not really using that at this point. Okay, well, whatever. Okay, we're in queuing a 3. So we want to in queue 3. We always in queue at the rear. The rear right now is 0, but if you notice here, we increment rear. It's kind of like rear plus plus, isn't it? The only problem is, and well, actually it is, because if it's 0 now it's a 1, which means rear is now here. And so we in queue a 3. But we don't say rear plus plus because of the situation when rear gets to right here. Rear plus plus would put rear right here at 10, and there is no 10. So that's why we do rear plus 1 mod psi. So every time it gets to 10, it goes back to 0. So it circles, doesn't it? It circles back around. That's nice. So rear and front are always changing. So the values that are put into the queue do not have to be moved or shifted. If we went back to this, let's just say, for example, we pushed a 1 and then a 4 and a 9, not pushed, in-queued, a 6 and a 3. So we in-queued 5 numbers, 1, 4, 9, and we started by in-queuing at the rear, and that was the rear at that time. Then this becomes the rear, we in-queued a 4, then this becomes the rear, we in-queued a 9, etc. And now we're going to dequeue, we in-queue at the back, the rear, and we dequeue, take it off, pop it off from the front. So this is the front. So we take the 1 off. Well, you can see the problem with that. If we take the 1 off there, if we keep this always as the front, then we would have to move this one up to here, and this one up to here, and this one up to here. See, that would be very inefficient. Every time we want to take one off, we would move everything else up. We don't want to do that. That would be horrible. So instead of moving the numbers, let me see if I can get lucky here and put this back in here. There we go. Instead of moving the numbers, we should just move front and rear. Move, change the numbers in the variables so then front and rear move through the array, but the numbers in the array don't move. Well, until we dequeue them. So in summary then, we always in queue at the rear and dequeue at the front. You got to remember that. That's an important part of what a queue data structure is and how it works. And the reason for that is because just by definition, a queue is a first in, first out. So it has to come out, the first one in is the first one out. So it has to go in at the back and come out at the front. So we in queue at the rear and dequeue at the front. And so therefore, we have to increment rear before we put it in, because that's where we're putting it in. We're in queuing at the rear. And so we have to increment rear, like rear plus plus, and then in queue. And likewise, if we want to dequeue, we take it off the queue, and then we decrement. Okay. No, I don't think I told you that correctly. I was kind of thinking about something else when I was talking. We have to increment front. We increment front or rear. I'm sorry. We have to increment front or rear first, and then we either in queue or dequeue. Okay. So in essence, the front and rear, they're just going to, front's going to go here, and then front goes to there, and front goes to there. If it's dequeuing, and rear goes to here, rear goes. So and then when it gets to the end, to in this case 9, if front is right here, and we're going to dequeue, we always dequeue at the front. Then we first increment front back to here, and then we take it off. So so the front and rear are just sort of cycling or circling around and round and round. The queue is if you think about it, the queue is circular, isn't it? the access to the array elements is circular. It gets to the end, and then it's, you know, front plus 1 mod size, or it's rear plus 1 mod size. Notice here on the is empty, remember going back to a stack, we knew when it was empty, if top equals -1, then it's empty. In this case, if front equals rear, it's empty. Because remember how this started out? Going back to the constructor here. If the front and rear are both assigned to the end, size -1, it's empty. And of course that means they're at the same place. That means that rear equals front, right? So that's what the constructor does. It puts them, and we discussed that earlier in this video, that you could actually assign it to be here or even -1. But anyway, the point is they have to be the same, and that means the queue is empty. Whenever front and rear are the same, it's empty. So going back to is empty, here it is. If front equals rear, it's empty. And is full? Rear plus 1 mod size equals front. Okay, let's follow this little scenario. Let's say we start out by enqueuing at 3. We always enqueue at the rear, but remember in that enqueue function, it's rear plus 1 mod size, which puts rear to 0. And then it enqueues at that point. So it would enqueue a 3. This becomes rear. And then enqueue a 4. Well, again, rear plus 1 mod size, which puts this to a 1. And so it enqueues a 4. Enqueue a 6, rear becomes a 2, puts a 6. And then a 7, a 9, and 11. 7, 9, 11, 5, 6, 7. I think this is a 7 now. Yeah, this is 11 here. Yeah. Am I doing that correctly? I should have gone more slowly. When we enqueued this, rear was 0. So rear is 1, rear is 2, rear is 3, rear is 4, rear is 5. Okay. I think I had a 5 and I just did it sloppily. Okay, well that makes sense. That means rear is right here because it was just enqueued. And then let's keep going here. Enqueue 17. But first rear is incremented to 6, and we put a 17 there. And then an 8. Yeah, sure, 8. So this increments to 7, and rear is now here, and it puts an 8 there. Okay, but going back to our program for just a second here. If we look at enqueue, here it is. Well, let's take a look at is full, because if we were going to enqueue, that's like push. Remember with the stack, we had that function is full. We said if not is full. In other words, if it's not full, then stack.push some number or something, whatever. Okay, so this would come in here and push it, providing that it's not full. Well, the same thing applies here. We don't want to push or enqueue into the queue if the queue is full. So if you notice here, it's checking to see if it's full. Now this could be done as an if. Again, this is just shorthand notation. But if rear plus 1 mod size equals front, then return true. See, in this case, that's what it's gonna evaluate that. If it's true, it returns true. If it's false, it returns false. So it's this if statement that I've written is the same thing as doing that right there. Okay, anyway, and so so in other words, we want to first check and make sure that it's not full before we enqueue. So just like with the stack, we would definitely want to check first. You don't want to overflow the stack or the queue. So we would say if not is full. If it's not full, then queue dot, this would be done in main, whatever it is, 77, who cares, right? But if it is full, then don't do it. Now, so then what is the criteria? What makes it full? Let's take a look at that. We know that if front and rear, if they're both pointing to the same one, it's empty. We saw that with the constructor above. If front and rear are the same, it's empty. But this is saying if rear plus 1 mod size equals front. Okay, let's go back to here. So we don't need all this stuff now. We're done with that. So what was it? If rear plus 1 mod size equals front, then it's full. Return true. So in this case, rear is 7 and front is 9. So what do we have here? Rear plus 1, that's 7 plus 1 is 8. If 8 mod 10, that's am I doing that correctly? Yeah. Equals front, which is 9. Well, that doesn't seem right. Let me stop it just so I can gather my thoughts here. Yeah, it's correct. I had to think about it for a second. So 8 mod 10 is 8, right? It's 8 because, you know, 10 goes into 8, 0, and the remainder equals 8. So makes sense. So that's fine. That's not full. And it makes sense. There's one there. So now let's say that we in queue one more, we put in a 14. And so rear is right there now, because it would be rear plus 1 mod size. So this is now 8. And now let's check to see if it's full now. Now rear is 8 plus 1. That's a 9. 9 mod size, which is 10. 9 mod size, and this would come out to 9 because you know, 9 divided by 10 is 0, and the remainder equals 9. So now 9 equals 9. So it's full whenever rear is I guess you could say one behind front. If rear plus 1 mod size equals front, it's full. So it's kind of iffy in that there's actually no, it's full, but technically there is one space not being used. I have actually in the past just written the code to correct that. I don't know if you want to call it a problem. I don't really look at it as a problem because let's say you need a queue in your program, and you might have as many as 20 items at a time that you want to in queue into the queue. So make the size of the queue 25 or 30. In other words, you can make the queue larger than you need. You know, you just want to play safe, make sure you have enough. But the fact that there's an extra one, at least as per this particular program as it's written, there's an extra spacer, but it really doesn't matter at all as long as it works, and it works fine. But again, it wouldn't take you long if you sat down and thought about it for a while. You could figure out how to correct that problem, but I just don't remember off the top of my head right now. So anyway, that's when it's full. It's not full when there's an item in all 10 spots. It's full whenever rear plus 1 mod size equals front, which is going to be this situation here. There will always be one extra space not being used. But don't worry about it. Don't get hung. Who cares? Just make the array bigger if you want to, but it's no big deal. So in summary, if it's empty, front and rear equal each other, and they could be anywhere, anywhere in here. If this is, if front is 5 and rear is 5, it's empty. Just however it works out. As far as being full, if rear plus 1 mod size equals front, it's full. Okay, here is main, just a little program. You can do this on your own if you want to, just to check it out. Here, I think this is kind of sketchy code. I don't think that's particularly good coding style. It works fine, but I don't know. I've heard people tell me that you're not supposed to use that, but while true. But anyway, that would basically create an infinite loop. But as long as you have the something that would break out of it, and there it is. If item equals -1, then break. So this is just allowing you to in-queue a bunch of items. Enter values -1 to quit. So it reads in the item that you enter, a 5 and a 7 and a 9 and a 2, and then whenever you're done, you enter -1. And if you enter -1, it breaks and the loop is done. But if it's not -1, it puts it in the queue. So it's a silly little program, but it shows that the queue works. And then here, and by the way, this, oh, that's kind of funny. So you can quit whenever you want, or right here you can use. So it does it one of two ways. Either it will quit whenever it's full, the loop will stop, it'll break, or it'll quit when you enter. It'll break when you enter -1. In this case, we're going to remove them from the queue. So queue.dequeue item, and it's going to do that as long as it's not empty, while not queue.is empty. So as long as it's true that it's not empty, it'll dequeue, but eventually it becomes false because it is empty. All right, and so now, having talked to you about stack and queue and so forth and so on, and how to do it and how to make it and blah blah blah, now you find that there's a standard template library for a stack. And so you don't have to know anything. All you got to do is know how to do it this way. But you do, because when you go to the university, they expect computer science majors to know how a stack works and how to develop a stack. You need that knowledge. But in the real world, of course, there's no point to making your own stack, because there's now a templated stack in the standard template library. And look at the function name size. We know what size is. Remember size with all, we did it with vector and list. If you have pushed 3 items onto the stack, then the size is 3. It's the number of items on the stack. And that was true with vector and so forth and so on. And we know what push is. Push item on, pop the item off. Now notice here there's actually 2, which we didn't discuss too. With the STL stack, pop removes the top element from the stack, but does not return it. Returns the top element, but does not remove it. So in other words, if you use top, here's the stack. Keep it real simple here. Let's say that this one is here's the top. So if you did something like this, cout, let's assume that it's called a stack. That's the name of your stack, stack.top. Remember, top returns the item, the 7. So if you did this, cout stack.top, the output would be 7. But it doesn't take it off the stack. There would still be a 7 on the stack, okay? If you wanted to take it off, display the 7, and then remove it, you would have to do first cout stack.top or whatever, and then stack.pop, and that would remove it off off the stack, and then top would be here. But we don't really care that with the STL, it keeps track of the top and all that stuff. You don't have to do any of that. So it's actually a 2-step process if you want to get the value back that's on the stack and also remove it from the stack. You have to top and pop. If you want to just pop it off the stack and not get the value, just remove it, then you would use just pop and it would remove it from the stack. There are some other functions that are available in the STL stack. I just listed a few of them here, but as you know, there's always, as always, the STL classes, they use the same function names for the most part, unless it's something specialized, like in the case of top. That would be something that would be pretty much exclusive to stack. It might be used in some other data structure, STL data structure. I'm not sure. Okay, here's just a little program, using, here's top and pop. Oops, where's it at here? Here it is. And just some push functions. And as you probably would guess, there's also an STL queue. Pound include queue. The previous one was pound include, up here was pound include stack. Pretty nice though, huh? You just use them. You don't have to create them. And look at here, front, they call it back, we called it rear, but either way, front and back, front and rear, doesn't matter. And there's a empty function, which we saw before with vectors and decks and lists. There's a size function and pop. So, by the way, they call it pop, they don't call it DQ. They're trying to keep a consistency, and push, not NQ. They're trying to keep a consistency with the names across all different STL classes. So vector, well, in vector it was called push back. But anyway, push and pop. And so here's a little program, pushing them on the queue or NQing them. Oops. And that pretty much concludes this lecture, this video, and this is the third and final video for lecture 6. So that's it.